Imagine the office bulletin board is the master schedule, and every morning you snap a photo of it before you head out for the day. You make your own plans based on that photo, but the Rail board keeps changing while you are gone. When you get back, you compare your photo to the live board to see what is new. The trouble starts when you try to pin your update over someone else's that went up after your snapshot, and the office manager stops you so nothing gets covered up. Your photo was never the board itself, only a remembered copy of where it stood. That gap between your snapshot and the live board is exactly how Git remotes and remote tracking branches work. Most developers cannot explain why a push gets rejected, why origin/main lags behind, or what a refspec is. That fog turns routine sync errors into guesswork and unsafe force pushes that overwrite real work. Git is distributed, so every clone holds the full object database. What connects you to a server is a remote, which is just a saved URL plus a refspec. A refspec is a mapping rule that says which refs on the remote correspond to which refs on your side. Remote tracking branches like origin/main are local read-only pointers that cache the last position you saw for the server's branches. A remote is stored in .git/config as a name like origin, a URL, and a fetch refspec, by default plus refs/heads/*, ref/remotes/origin/star. That refspec means take every branch under refs/heads on the server and store it locally under refs/remotes/origin with the same name. Git fetch opens a connection over HTTPS or SSH, negotiates which commit objects you are missing, downloads them in a pack file, and updates your origin/* pointers, but never touches your local branches or files. So origin/main moves only when you fetch, which is why it can sit behind the real server until you sync. Git pull is simply git fetch followed by a merge or rebase of origin/main into your current branch, which is the step that can change your working tree. Git push reverses the direction. It sends commit objects the server lacks and asks the server to move its branch ref to your commit. The server accepts only if your commit is a direct descendant of its current tip, a fast forward, otherwise it rejects the push to avoid silently dropping commits that arrived after your last fetch. A force push with force overrides that safety, and the safer force with least ref uses unless the remote still matches the position you last fetched, protecting against overriding a teammate. You and a colleague both branch from main at commit C. You commit D and push, moving the server tip to D. Your colleague, still at C, commits E and tries to push. The server rejects it because E is not a descendant of D that would erase your commit. Your colleague fetches D, rebuses E on top to get E prime, then pushes successfully, and the history stays intact. The core misconception is that origin/main is the live branch on the server. It is not. It is a cache snapshot that updates only on fetch, so it can disagree with the real remote at any moment. A second mistake is treating a rejected push as a bug, when it is Git protecting commits that landed upstream since your last sync. The fix is to fetch and integrate, not to force push. A remote is a URL plus a refspec mapping. Remote tracking branches are cache pointers refreshed only by fetch, and push is a fast-forward request the server rejects whenever accepting it would erase commits you have not yet pulled. Just like that snapshot of the bulletin board, your local view of the server is only as fresh as the last time you looked. I make the network side of your tools finally make sense every day, so subscribe to Tech with Joel. Have you ever force pushed and regretted it? Confess the story in the comments. Subscribe to Tech with Joel.